Assalamu alaikum. Today on Neuron Academy, we discuss Blue Origin's TeraWave project. If you benefit, please support by subscribing and sharing as a sadaqah. Now, we're going to look past the rockets for a moment, to something that could be even more impactful, the invisible highways of the future. Blue Origin is betting billions on a project called TeraWave, and their plan is to build the essential data infrastructure for the AI age, right up in orbit. This could literally change how our world moves information.
So, this really gets to the heart of the matter. It's the one big question driving this whole massive project. With the explosion in AI and cloud computing, can our networks on the ground actually handle the load? I mean, we rely on fiber and these huge subsea cables, and yeah, they're fast, but they're also surprisingly fragile. What happens when our demand for data completely outpaces what the ground can provide?
We've really hit a new stage in the digital economy. For the biggest AI models, for massive cloud data centers that have to sync constantly, for governments that need secure global links, the main challenge isn't a lack of computing power anymore. The real problem, the new bottleneck, is actually moving all that data from point A to point B. And this right here, this is a huge shift in the industry. It's not about processing power anymore, it's all about data transport. And if you get that, you start to see why a rocket company is willing to bet billions on a data network in space. They're trying to solve the next big problem before it grinds everything to a halt.
So this is where TeraWave comes into the picture. This project is a major pivot for Blue Origin. They're going from just being a launch company to becoming a provider of space-based infrastructure. And let's be super clear about this. This is not about getting faster internet to your home. This is about building heavy-duty, enterprise-grade data highways in orbit.
So how does this whole thing work? Well, at its core, TeraWave is what's called a hybrid satellite constellation. It sounds complicated, but it just means they're combining two different types of satellite orbits into one big, resilient mesh network. The goal is to get the best of both worlds. Let's see what that actually looks like.
All right, let's break this down. First, the network uses satellites in low Earth orbit, or LEO. Their biggest advantage is crazy low latency. Think of them as the sprinters of the network. They get data there incredibly fast. But then, they're combined with satellites in medium Earth orbit, or MEO, and these are the long-haul trucks built to handle massive amounts of data. Put them together, and you get both speed and scale.
Okay, now the way the data moves is what's really crucial here. Instead of bouncing all over the globe through this messy web of ground cables, the process is way more direct. Data gets sent up to a satellite. It zips across the world from one satellite to another using lasers, and then it's beamed back down to where it needs to go. That means fewer ground stops, less delay, and a whole lot more security.
So, if this isn't for streaming movies or playing games at home, who exactly is it for? It's really important to understand that TeraWave isn't being built for you and me. This is a highly specialized industrial strength service for a very specific kind of customer. We're not talking about a market of millions of people here. We're talking about a handful of giants. The world's biggest data centers, the top AI companies training those huge models, and government agencies with critical national security needs. The customer list might be short, but their demand for data is just astronomical.
So why would these customers pay a premium for this service? Well, because for them, network downtime isn't just an annoyance. It's a multi-million-dollar disaster. One cut to a single undersea cable can bring their operations to a standstill. TeraWave is offering more than just a backup. It's a strategic asset. As one source put it, it's like insurance for the global data economy. It's the high ground.
Now, none of this is going to be easy, and it is definitely not a guaranteed success. This whole project is a monumental gamble, both financially and technologically. It's a really high-stakes bet in a market that's already crowded and incredibly difficult to succeed in.
This table really helps clarify the whole landscape. You've got SpaceX's Starlink, which is all about getting internet to the masses. Then you have Amazon's Project Cooper, which is aiming for a mix of regular broadband and business customers. But TeraWave is positioning itself completely differently. They're not going for the mass market. They're a premium, high-capacity infrastructure provider for a very select group.
And the challenges here are just immense. I mean, how do you cool down powerful electronics in the vacuum of space? How do you maintain an upgraded constellation with thousands of satellites? And maybe the biggest hurdle of all, how do you possibly fund the staggering cost of launching all of this, knowing that you might not see a profit for years, maybe even a decade?
So why does Blue Origin think it can actually succeed? Well, their secret weapon, their core belief, is in vertical integration. By planning to use their own heavy-lift rockets, like New Glenn, they think they can control one of the single biggest costs and risks in a project like this, the price and the schedule of just getting to orbit.
All right, let's just zoom out for a minute. This isn't just a story about a new satellite network. This is really about who is going to build and who is going to control the next fundamental layer of our global infrastructure. And that has huge implications for the future.
To put it into perspective, just think about how building the interstate highway system, or the railroads before that, completely reshaped entire economies in the 20th century. That is the potential scale we are talking about here. These orbital data networks could become the essential infrastructure that defines the entire AI era of the 21st century.
And that brings us to this final, really thought-provoking idea. If projects like TeraWave succeed, space won't just be a place we visit anymore. It'll become a core, integrated part of the internet itself. And if that happens, the defining race of this century won't be about who has the best rockets. It will be about who controls the data.
Presented and created by Neuron Studio.